Check that. Let's see our today's problem, fair distribution of cookies. It says you're given a integer array cookies where cookie I denote the number of cookies in the ith bag. You're also given an integer k that denotes the number of children to distribute all the bags of cookies to. All the cookies in the same bag must go to the same person. The unfairness of distribution is defined as the maximum total cookies obtained from a single child in the distribution. We need to return the minimum unfairness among all the distribution that could happen. Let's understand it via an example. So we have here this test case given to us. So we can distribute this cookie as part of into two childs. We can give bag 1 and bag 2 and the remaining bags to the other child. That could be one distribution. And here to calculate the unfairness we can say, okay, the summation of first two is 23, the summation of others two is 38. We need to pull the maximum out of this, that is 38. Similarly, the other division could be 10, 8, 8 could be in one bag, and 10 and 15 could go in the other bag. So it should be 20, right? So 20 should go to the other bag. So here in this case the distribution can result in 26 comma 35 and the maximum is 35 here, and out of these two the minimum is 31 so far. So similarly, whatever the combinations that we have of the distribution, we need to find the minimum unfairness across all the distributions. So with this distribution the unfairness is 38, with this distribution the unfairness is 35. We need to come up with the distribution that will result in minimum unfairness. So as part of the simulation, we know, okay, we are trying to give this candy or give this back to student 1, give this back to student 1 or student 2. So we have two choices here. Let's say what happens if we have three choices. Then we'll say, okay, this first bag would go to student 1, student 2, student 3. Similarly, the second bag can go to student 1, student 2, student 3. All they will have three choices. So that means the number of choices the bag would have is equal to the number of children that bag could be given to any of the student, right? Let's see if we have 8 students, what will be okay, we have here 5 students. So that means each student will get one bag. It doesn't matter which student gets which one in this case, because our number of bags is equal to the number of students. So in this case, no matter what distribution is, whether 8 goes to the child 1 or 15 goes to child 1, doesn't matter, because we are interested in minimum unfairness, and in this case the answer would be the maximum of this integer array, right? So that will be our base case. Let's just code it up. So we'll say if my k is equal to cookies dot length. I don't need to think much. I just need to find the maximum cookie that I have in this cookies array, right? So that will be my answer. So let's have the maximum from this cookie. So I can directly return this max. So let's define this max as well, and max is equal to the min value. Okay, so now let's say if it has just one, we have one student, that means all the bags will go to them. In this case your answer will be the total of all. uh, let's see some of the constraint that we have. Okay, it says cookies dot length can be till 8, maximum 8 student we can have, because that's what k is also restricted to. And the each individual cookie count can be go to 10 raised to the power 5. Okay, so we'll have at max 8 cookies, each will have maximum value is 10 raised to the power 5, so that will still range in the bounds of int. So now what we need to do is we need to come up with all the possibilities of the distribution, all the valid distribution, so that they can be distributed among the given k childs, and from those distributions we need to find the maximum, and out of all these maximums we need to find the minimum. So let's try to code that up. This sounds a recursive process where we'll say, okay, let's try giving the first bag to student 1, let's try giving the first bag to student 2. So based upon the how many students we have, we'll try that way. So let's try it out and say we are creating a function called helper. Now for this we need to keep track, okay, which students get what bag, right, or how many cookies does each student get. Let's keep a map to track that, which will have integer comma integer key value pair. We'll have a map here. Now in this case, okay, let's pass it to the signature. This will map the student versus the number of cookies that it has. And then now we got our map. We need to know which student do we talk about, or how many students are there. Let's say that represented by k, the number of students that we have. And then we can say, okay, which student currently I'm talking about. Let's call it as maybe child 1. So that is your child, the current child. So now we can say if my, so we need to know the total childs, but here we need to know how many cookies that we have, right? So we have the total of bags, and we are talking about, do we want to distribute the first bag to the other child. So we'll have here the bag index, and we'll say, okay, if index is less than my cookies dot length, that means I still need to process, I still need to distribute that ith bag. Let's pass that cookies as well. So now I know, okay, this is a valid case where my current bag is less than the total number of bags. So I need to distribute this bag, but I can distribute this bag to any of the child. So that will say, okay, child initially is 0, and then I can say, okay, child less than my, the total number of childs that I have, and child plus plus. Then we can say I need to distribute this cookie, right? So let's say map put for this child, and also get what initially the child would have. Let's use this getter default here in case this wasn't available earlier. So we need to give that many cookies to this child. uh, okay, yeah. So now we know, okay, child 0 got this cookie. After that we need to say, okay, I need to call this function again with the same number of cookies, same number of total children, but with an index as +1. And then again it will loop over which child we want to give the second back to. So it again want to give to child 0 or the other one that we don't care. But once it backtrack, we know we want to put the same child, get that cookie back. You can just subtract that value, and that looks like it. So now here we have else. What it could be like, if index is equal to cookies dot length, then that means, okay, all the bags are given, and that's why we ran out of index here. All the bags were distributed. At this time we want to, let's say, traverse through our map, traverse through our distribution. So let's create that function as well. Public void, let's just copy this and do this. So we have a distribution here. So what I'm going to do, I'm saying, okay, we'll have some integer, we'll get some key, get that key. Okay, and you get that value. We need to say what is the maximum that I can get out of this. What is the max, who has the maximum distribution, and what is the amount that the child has. So it has this maximum, then out of this distribution I need to keep track of the minimum overall. So let's say max is equal to integer dot, or maybe we can just say put it as 0. Yes, we don't have negatives, right? Okay, so now the minimum is this. We have int minimum is equal to integer dot max value, but we need to call this function, right? We need to call this map. We'll pass how many cookies we have, how many childs we have, how many index that you want to start upon. So we need to start upon with the 0th child, and then we'll traverse through it. It will update the minimum on the fly once it reaches that count. Now let's just try to run it, but we are not returning anything, one thing. So this is minimum of this. Let's try to run it. Okay, looks like this is working fine. So here we are traversing through all of the combinations. We are checking, okay, what is happening here. Let's try to sum it. Okay, it passed. If you see, there is, so it only beats 16%. Let's try to see if we can optimize this. So in our current flow, we are distributing every cookie to child 0 always. So there will be some chances like the other childs are left with 0 cookies. We are might not be keeping track of that iteration. Let's just verify that. If I just print the map in between here, so this will depict me, okay, how many cookies does each child hold. So you see 0 child got 53, 1 got 8, 0 child got 53, 1 got 0. So this is an invalid distribution. Why I'm taking care of this? Why do I need to proceed further down this path? Similarly, this also is an invalid path. So we can get rid of those paths while we can keep track, okay, how many cookies does each child receive one cookie or not, or we can just break out of that recursion. So how I'm going to keep track of that is, we can say, okay, so we do need how many childs are still left to distribute a cookie. So let's have that value as k, because at the starting we'll have none of them has got any cookie, right? So let's have number of childs left as this. So now here we have okay, so here we put that as child left initially was, let's say in our case 2, but we need to keep subtracting this value, whatever the value does this has earlier. If it is 0, we need to say, okay, subtract 1, otherwise we can subtract 0. So at this point, what we're calculating the number of childs left. So if initially it was 0, I know at this point I'm going to give him some cookie. So I can say, okay, the number of child left is now just 1 because this one just got it. And after that, once I remove this, and after my removal, if this is still 0, I can add back that here. So now we thought, okay, let's not give back 1 to child 1. So the number of child left will be increased because we just had minus it and we are incrementing it once we backtrack it. So at here we can say how many bags do I have left and how many children do I have left. So the number of bags that are left are cookies dot length minus my index, right? So that is the number of bags left. Let's maybe define a new variable. Let's say bags left to process is this. So if this bags left is less than the number of childs left, right? That is clearly an invalid case because there are more childs and we don't have much bags. We can't distribute that, so we can return it. So let's try to run it again. We are not passing that child left. Okay, it says accepted. Let's try to submit and see our complexity again. Yeah, this time it paid 63%, which is good enough from the last 14%. Yeah, we saw we got around 68%. Let's see if we can maybe optimize it a little further. So we were printing a map here. Let's just print a map once the iteration is done. Let's see how it behaves. We'll have maybe 3 childs. So yeah, you see we still have some student who didn't get any of the cookie and we're still iterating through that path. So what we can say here, we are subtracting that cookie from that child, but we don't want to proceed this path, right? So once the 0th child would be left with 0 cookie, we don't want to proceed that iteration itself. So yeah, we are talking about these iterations. We maybe can get rid of this iteration altogether. So for that, what we can do, we can say, okay, what is the how many cookies does this child have? If it has 0 cookies, I don't want to proceed again this path. We can just break out of it. I just try to run it. Okay, looks like it accepted the initial test cases. Let's hit submit. Yeah, this is way better. We got almost 90%. So yeah, that was about it. So it was recursive based algorithm where we have tried to distribute the bags to each of the childs and find the maximum, and out of all of the distributions we are finding the minimum through traversing that map with invalidating some of the invalid distributions. So yeah, thank you.